Hi, George Matthews, Building Energy Compliance Testing. Today we are in Berkeley, California, and we're going to test a 100-year-old house for combustion safety. We've got two brand new water heaters, and the city wants to make sure that these water heaters are actually safe and that the combustion gases are going up the flue where they belong and not in the living space where they're going to kill somebody. Okay, we're down in the basement of this Berkeley house, and we're looking at the two atmospherically combusted water heaters. The city is concerned that these are not going to be able to move enough of their combustion gases up the flue, and they might allow combustion gases out here and asphyxiate the people who live here. Obviously that's not good, so we want to do a little test today and see if they're actually working or if they need to be modified so they move the combustion gases out of the house. So first of all, we're going to drill some holes in the flue. We're going to drill the holes up here in the middle of the flue where we've got a nice flow, supposed to have a nice flow through here, and we're going to measure the pressure. We're also going to measure right here, and then we're going to take a combustion analyzer and stick it down there into where we've got pure flue gases, and we're going to see how many parts per million of carbon monoxide we have. We're going to do that to both these. What we want to make sure is that they have a really low percentage of carbon monoxide. If they've got, I've seen older equipment where you start measuring and all of a sudden you see 100, 200, 300, 400, 500, 900 parts per million of carbon monoxide, stuff like that. Boom, it's red tagged, it's no good. That machine needs to be gotten rid of, replaced, or fixed. Okay, now we're measuring the water heater for the upper floor. We're getting this down into the inside the unit where it's just pure combustion gas. And you can see starting to rise here, 4 parts per million, 5. And we just wait a moment and it just rises as the testing apparatus pulls the combustion gases through it and analyzes it. Looks like it's kind of leveled out there at 18 parts per million, 19. Anyway, if these are the kind of units that get red tagged, they'll just start skyrocketing. The numbers will just start shooting up, but this is really consistent. So that's what we want to see. We're 20, so that's not something that's going to kill somebody right away. But anyway, we've already established that this is moving air up the flue. So this is a very clean burning unit. It's brand new and that's just what we'd expect. But it's still half of the carbon monoxide of this one. Right now we're in the basement and it's all closed up. All the windows and doors are closed up and we're in what's called worst case scenario. Each water heater is on and the furnace is on. So they're all pulling air from inside here and they're combusting it. The furnace is sending the combustion gases up this PVC flue pipe. It's more efficient than these. These use metal, and the gas is flowing up here. So we're not even at -1 Pascal. So this is not a depressurized room. If this was a super tight, brand new house, and if there wasn't enough air coming in, we'd be at a really negative pressure. So the BPI, Building Performance Institute, says we can go up to -5 Pascals, but we're not getting anywhere near that. So this is not a dangerous situation. We've got plenty of fresh air coming in right here for all 3 of these combustion appliances. Because of that, we know we're safe and the combustion gases are going to go up the flue.